Okay, these three, the last one has something that is a little new. Not majorly new, but a little new. If I make a checklist of things, number one is the x-intercept. The x-intercept would occur when these factor terms were zero. That would happen at -3, at +1, and at +4. First thing that we do. Second thing on my list was semi-expand. So I'm just looking for the first term, I'm looking for the constant term. The first term is going to be x to the 4th, bunch of stuff I don't care about. The last term, do in 2 swipes. First one is going to be, is it positive or negative? Second is going to be how big it is. I look for negatives, I count 2 of them. 2 negatives are going to make a positive. Next, I look for magnitudes. I see 3 times 3 times 1 times 4. You have to count the 3 twice because it was squared. 9 times 1 times 4, I am getting 36. So somewhere around here, I'm going to put my y-intercept. I can label now, or I can label later. Oh, sorry, that was step 3. Y-intercept. Step 4, I look at the lead coefficient. That's going to tell me tail behavior. I've got 2 different tests. I'm going to do them in order. First off, the coefficient in front. If a is greater than 0, it ends high. If a is less than 0, it ends low. In this case, a would be a 1. The first term is 1 times x to the 4th. We never bother writing the 1. This is a situation where a is positive, so I know that it ends high. The second, where it begins, you look at odd, even. If it's odd, then it's going to start opposite. If it's even, it's going to start the same. Even number, ends high, starts the same, starts high. 5. Single roots pass through. Double roots bounce. And this is actually where I draw the thing. Now, typically, I'm going to be kind to you, and I'm going to send it from left to right. X plus 3 goes with the furthest left. X minus 1 goes with the next one. X minus 4 goes with the last one. There is an exception, and you're going to see that on the third one. But for now, I'm just going to go from left to right. I start high. This is a squared term, so this is a bounce. It's got to turn back around, go through here, and it's coming up to this term. That's a single term, so that is a pass-through. This distance was 4, this distance is 3, so I'll probably turn back around a little bit quicker. I want this to be a bit higher than that because this is wider than that is. That is my graph. I'm not done yet. 6. Check. Labels. If it's at a tick mark, and I only have to count at most 7 ticks, you don't need to label it. If it's not on an axis, if it's on the field, even though it's obvious that it's over 1 and up 2, that that's what you intended, I still need it labeled. Anything in the field, anything in one of the 4 quadrants has to be labeled. And I am not going to make 36 tick marks. So the y-intercept has to be labeled. So this is going to be the point 0, 36. So that's the first one. Second one. Same process. Number 1, x-intercepts at -2, at +2, at +5. First thing, quick and easy. Second step, semi-expand. -3 x cubed. None of these are repeated, so it's just -3 times x times x times x. Plus a bunch of stuff I don't care about. Last term, count the negatives. It's going to be negative, negative, negative. 3 negatives. Well, when you start with 3, you can cancel a pair of them, but that still leaves you with a negative number. So that's going to be a minus. 3 times 2 times 2 times 5. 60. Anybody else getting 60? I like grouping the 5 and the 2. I like seeing 10. Multiplying by 10 is easy. And then I group these two together. 6 times 10 is 60. I'm just going to put it up here somewhere. Tail behavior. First time I indicated it this way. This time I'm going to do the alternative labeling. First coefficient is a -3. That's a negative, so it ends low. It's odd, so it starts opposite. So this will be high to low. Now, hold on 1 second. So it starts high. I messed up. I messed up the y-intercept. I kept track of the 60. You don't get to say it. Nobody else is saying it. But what did I do wrong with my y-intercept?
It's supposed to be
It's
negative.
negative, which is below the axis. Now, here's one nice thing about this process. I messed up, but I got to this point and I knew I had to start high This was a single root I had to pass through. I can't really turn around and get to a point up there. So I actually used my knowledge of the shape to recognize that I'd better check my y-intercept. It really belonged up there. Single root, single root, single root. All single roots, so these are just all pass-throughs. This one should be relatively simple. With all single roots, it's gonna look like this. This distance is 4, this is only 3, so I'll make the next one a little bit shorter. Check labels, 0, comma, minus 60. Look okay? Third one. The new thing is the x squared term. Traditionally, if you got a plain old x term, it gets put in front and not in order. If I wanted to, I could rewrite this in order, in the same form as all of the others. It would look like this. I'd replace the x squared with an x minus 0 squared, and I'd put the 0 between the -3 and the 5. But the tendency is that we would write this. We wouldn't write, for example, x plus 3, x squared, x minus 5. When we've got a plain term, we bring it out front, which has the strange effect of meaning that it no longer reads nicely from left to right. The other strange feature of this is here, I had 3 x-intercepts and a y-intercept. Here, 3 x-intercepts and a y-intercept. Here, it's 0 when x is a -3. It's 0 when x is 0. It's 0 when x is 5. Do you see that point right there on the origin? It is both an x-intercept and a y-intercept. Personally, that makes me less comfortable because I like having the y-intercept to kind of check to make sure I'm on the right track. I just have a little bit less information. If I multiply stuff out, what is my constant term going to be? I think I heard it. 0. I don't have a constant. As a matter of fact, my last term is going to be a -15x squared. Just 3 times -5 is -15 times x squared. So I don't have a constant term, I don't have an x term. This is just missing a whole lot of stuff. But I'm still going to trust the process. Like with the first problem, a is 1, a positive number, so it ends high. Four is an even number, so it starts the same. With 4, I kind of expect it to look kind of like a W shape. Now when you graph it from left to right, your hand doesn't move from left to right. The first thing you run into is the thing in the middle. You have to turn back around so you can get to the origin. That's associated with this. You're gonna bounce because it's second order. You're gonna go probably a little bit lower because this is 3 and this is 5. Turn back around, pass through, and that's gonna be a single root. Not my best graph, but it looks something like that. Any questions? Polynomials. Okay. Circle up groups of 3 and 4. Could you get it done in 5 minutes? Get started. If you know exactly what you're doing, -2, dot, +1, dot, +6, dot. Semi-expand, -2x to the 4th, bunch of stuff, negative, 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 4 negatives make a positive, 2 for 24. So I'm gonna put it somewhere like that. Next, negative, so it ends low, even, so it starts low. I'm kind of expecting that this one is going to be M-shaped. I'm gonna start low. I'm gonna pass through there, turn around, hit my y-intercept, come down to 1. 1 is where the bounce occurs. I'm gonna go back up, come down, and pass through.
Wait, do you know square?
Excuse me. The last thing I'm gonna do is write 0, 24. So that's kind of how this works. I didn't speed through that. I took it deliberately, but I was always writing. It took me 2 minutes. So you can get through questions that you know exactly what to do in kind of a 2-minute framework. Sounds easy. But then there are problems which are going to slow you down. If you could do this problem in 5 minutes, you're well on your way. Second major thing I want to look at. Something like this, something like that. Yep.
What was the rule to I decided where the line is, where it would end? What was starting, where it would end?
It ends low if the coefficient in front of the lead term is negative. If the coefficient. Then you figure out starting position dependent on whether it's odd or even. Once you know it ends low, if it was an odd function, it would have started high. If it was an even function, it would have started low. I wish there was a start-finish rule instead of a finish-start rule. Because knowing that we'll look for first, people would dearly love to know where it starts. But I figure out the ending and then figure out the beginning. It's actually the easiest way. These, I've got a more complicated checklist. I need to find the x-intercept, the y-intercept, the vertical asymptotes, the horizontal asymptote. You can do it in different order. You have to look different places. It helps if you look at two versions. Here I've only given you one version. The other version, in this case, would be the expanded form. You'll have the factored form, the expanded form. In the expanded form, this would be x squared plus x minus 6. This would be x squared minus 1. Some of the stuff I tell by looking here, some I tell by looking here. So get the two versions, read off these four things. Next, graph it from left to right, respecting the points and the dashed lines. So it looks like a shorter list, but let's see what happens. The x-intercept, I look here. If x is -3, the top is 0, whole thing is 0. If x is +2, the top is 0, the whole thing is 0. Y-intercept, I look here. That's because if x is 0, these x's disappear. So when x is 0, the top is -6, the bottom is 1. That's going to be somewhere around here. Decide whether you want to do tick marks or not. 6 isn't a horrible number, so I guess I will. So if that's 6, that's 3, there. The advantage is now I don't have to label the thing. Asymptotes. You're going to look down here for the vertical asymptotes. So that's going to be when x is a -1, label it. And when x is a +1, label it. Oh, these two, you should definitely label. The others are typically at a tick mark at an axis. The exception is if this had been something like 6/4. 6/4 is the same as 3/2. That's 1.5. So it's not at a tick mark, it's between. If you're between tick marks, you label. Horizontal asymptote. I'm looking here. The ratio of the lead terms. X squared over x squared is 1. So y = 1 is going to be the horizontal asymptote. Next step sounds scary. It's going to be graph the thing. You are going to start on the left by the horizontal asymptote. So I'm starting somewhere out here. That's where I start. Next, pass through points. Respect vertical asymptotes. The next thing that I see is a point. That's a single. I won't bother with doubles on the test. So that's a single, so that's going to be a pass-through. Next thing I run into is a vertical asymptote. Vertical asymptotes either goes up or goes down. If that's the next thing you have to do, just check and see which side of the x-axis are you on. Are you above the x-axis? Keeps going up. Below the x-axis? It keeps going down. In this case, you are below the x-axis, so it is going to keep heading downward, like that. Next rule, if the vertical asymptote is from a single root, that means that if one side goes up, the other side goes down. They're going to differ. In this case, since it went down, coming from the left, it has to come from above on the other side of that line. The next thing I have to worry about is that point right there. Yeah, let's not do that. Let's just do this for simplicity. So I have to go through that point. That is a perfectly good point. That's a y-intercept. The next thing I have to worry about is another vertical asymptote. So again, I just ask myself that same question. Am I above, in which case I'm going to zoom up, or am I below the x-axis, in which case I'm going to zoom down? Currently, I am above. So it's got to zoom up. It's got to turn around and head up, something like that. If it went high on one side, I expect it to come from low on the other side, because single roots, they are going to differ. If it's coming from low, the next thing that I worry about is this point right here. There's no points, no vertical asymptotes on the other side, so the last thing I have to do is flatten. So I just move from left to right, and I graph the thing. Yes.
Do you mind giving us at least like one more of the last problem?
Well, I'm going to do this. The shapes can be different. A lot depends on where the vertical asymptotes are in relation to the points. In this case, I go back 4 point, I go forward 1 point. If I'm at -1, I've got a dashed line. If I'm at +2, I've got a dashed line. Now, those points, here I had one in zone 1 before the first vertical asymptote. I had one in zone 3. I didn't have any in this zone 2 area. Here I had one in zone 1, one in zone 2, but none in zone 3. It's possible to put both of them in one of the 3 zones, both of the points in one of the 3 zones. But this is a fairly standard. That's what I have looking at this form. The other form, it would look like x squared plus 3x minus 4 over x squared minus x minus 2. X squared over x squared is 1. That is my horizontal asymptote. I forgot to label, let me do that now. X equals a -1, x equals a +2, y equals 1. My y-intercept, I look here, because if x is 0, all of that disappears. y is going to be -4 over -2, which is a +2. So it looks like that. Read from left to right, handle the points and the dashed lines in order. All of them are single, and the rule for single is points, you pass through. Dashed lines, one will rise, one will fall. So when I see this, I come in, I pass through, I'm trapped below, I go down. It comes from up high, passes through the y-intercept, passes through the x-intercept, continues going down, comes from on high, and flattens. Let me have you practice just that last bit. I am going to start by, I'm not even going to show you the equation of the line, because I don't do this from the equation. I'm just going to show you the points and the dashed lines. All of the roots are single. I'm not even showing you what the equation is, but I'll tell you that after I ran the equation, I got those. Oh, sorry, I need to tell you one more thing. Yeah. Hold on. No, I messed up. There. Let me give you a couple minutes to try to figure out the graph. Just given the points and the dashed lines. This bit is following a recipe. Graphing it is understanding a few rules. Horizontal asymptote. The first thing I see is a vertical. I'm currently above the axis, so it's got to go high. Above the axis, go high. Below the axis, go low. It's got to come from the opposite side. Next, I see a point pass through, another point pass through. Now I'm trapped above. I'm above the axis. So again, I've got to go high. If that side went high, the other side has to come from low. The next thing I see is a point. I pass through. The last thing I see is a horizontal asymptote. I flatten. That is my graph. Now, this one, I'm not sure if I can call this a 5-minute problem. It's the toughest graph. But if you figure 3 minutes to put the stuff, the dots and the dashes on, 2 minutes to draw it, that's what would be the 5-minute problem. Let's try this as a 5-minute problem. Notice I was a little bit less kind to you. I gave you the expanded form. So the first thing you might want to do is factor top and bottom. But let me give you 5 minutes, see what you do.